Hi children, welcome to my YouTube channel. This is the first video of the video series, The Probability. What is probability? The probability is used to predict the chance of something happening. For example, if you want to find out the probability of occurrence of accident in a road junction. So you can calculate from our previous information. To get previous information, we have to conduct some experiment. What do you mean by an experiment? Experiment is the repeatable process that gives a rise of number of outcomes. To understand the previous situation, we need to identify how many road accidents occurs in that junction in previous few months. If you go into more history in that junction, you get more information that gives you more reliable answer of calculating probability of occurring the accidents in that road junction. What do you mean by an event? Event is a collection of one or more outcomes. For example, if you throw a dice, you can understand that occurring one is a one event in that experiment. But if you throw two dice simultaneously, you get different information, just like the side 1 in first dice and side 1 in second dice, and side 1 is first die and side 2 in other side. That like in a one event contains few number of observations. Therefore, event is a collection of one or more outcomes. What do you mean by a sample space? We know that when you get outcomes in an experiment, we should be able to record that information for future access. The way of representing information or collection of events or elements in a certain experiment is called the sample space. But remember, for a sample space, we need to include all the elements or all the events in that experiment. Therefore, the sample space is the collection of all the outcomes in a certain experiment. For an example, we know that if you throw a six-sided dice, you may obtain the elements from 1 to 6. Therefore, the sample space should include all the elements 1 to 6 including them. That is what I mean. So when you are working out the sample space, you should include all the possible outcomes in that experiment. Let's try to work out few examples to get more idea about probability. Example 1 means two fair spinners each have four sides numbered from 1 to 4. Therefore, the sides mentioned in two spinners, both spinners mark it as 1, 2, 3 and 4. The two spinners are spun together and the sum of the numbers are indicated on each spinner is recorded. Find the probability of spinner including a sum of exactly 5 and more than 5. Let's see how to mark this information in a sample space. We know that spinner 1 may obtain the elements 1, 2, 3 or 4. The spinner 2 should obtain the elements 1, 2, 3, 4. Likewise, if you mark this information on this sample space, you can say that what do you mean by this? The first space it fill up with this sample space, that is 1 and 1. That means spinner 1 indicates side 1 as well as spinner 2 also indicates side 1. In the sample space it mentioned we are recording the sum of them. So if you get side 1 in spinner 1 and side 1 in spinner 2, you will obtain the sum as 2. So let's go to the value ahead than that. That is 1 obtained in spinner 1 and 2 obtained in spinner 2. So if you add them together, that is 3. Likewise, you can fill up the sample space for all the elements or all the outcomes explained in this experiment. Right. Then let's see the first probability we need to find is exactly 5. So you can say what are the elements and how many elements are there where you get exactly 5. So you can say there are 4 elements which is in the diagonal, that is the elements with sum of 5. Now see whether how many elements are there total in this experiment. So you can say totally there are 16 elements in this experiment. You can count them, that should be 16. Therefore, the probability of occurring exactly 5 is 4 outcomes out of 16. If you simplify it further, it will turn up to 1 over 4. Then we need to find out the probability of occurring more than 5. See whether how many elements are there more than 5. That is 3 6s, 2 7s and 1 8. That means there should be 6 elements more than 5. All out of there are totally 16 elements are there. Therefore the probability would be 3 out of 8. In example 2, the question given is the table shows the time taken in minutes for a group of students to complete the number of puzzle. For example, there are 6 students, they took 5 to 7 minutes to complete that puzzle. Now in the second set, they took 7 to 9 minutes to complete that puzzle. There are 13 students in that column. Likewise, you have that set of information. The first question is, find the probability that a randomly selected student finishes the number of puzzle in 9 minutes. Now see whether how many people who have completed this puzzle under 9 minutes. So you can say below 9 there are 2 categories, that is 7 to 9 and 5 to 7, both categories are below 9. So in those categories there should be 6 plus 13, 19 elements are there. Totally, if you add up the elements in this group, you can understand that there are 40 elements. Therefore, the probability of completing the number of puzzles under 9 minutes would be 19 out of 40. The next question is, what the probability of completing in over 10.5 minutes, that is more than 10.5 minutes. Now you can see, if you count out the figures, more than 10.5 minutes, the last 2 categories 11 to 13 definitely more than 10.5 minutes. Therefore you can include the number of elements in that category. 13 to 15 also more than 10.5 minutes. Therefore you can count those 2 information clearly. 5 plus 4 added to this information in that way. Then we know that if we talk about more than 10.5, part of a category in 9 to 11 also included into this category. That means there are 12 elements from 9 to 11 category, part of a category, that is 10.5 to 11 also should be included into the sum when you are working out with this question. Then how do we calculate the number of information from 10.5 to 11? That is the important part. We know that 10.5 to 11 is in the category of 9 to 11. We assume that these 12 information distribute evenly in this category, and we will use this proportion method to count the number of information from 10.5 to 11. So we know that from 9 to 11 the gap is 2. For a gap of 2 there are 12 elements. We know that from 10.5 to 11 the gap is how much? The gap is 0.5. Therefore we use the proportion. For a gap of 2 we have 12 information. Then for a gap of 0.5, how many informations are available? With that you can say 12 per 2. Therefore you can divide 12 by 2 and multiply by 0.5. You will obtain 3 information. Therefore you can say that from 10.5 to 11 there are 3 information. 10 to 13 there are 5 information. 13 to 15 there are 4 information. Altogether 12 information out of 40. Your final answer should be 3 out of 10. In this question, they mention the length in centimeters for 220 koalas are recorded in a table. One koala is chosen at random. Find the probability that koala is a female and koala is a male between 75 centimeters to 85 centimeters. Here the information given in a table format. There's another way of representing this information. Now see whether the probability of koala is a female. There are altogether 240 colas. Therefore, you can represent the denominator as 240. That is the total number of elements. Now see whether how many female colas are there. How do you find it? Now count how many female colas are there. In the first category, there are 14 colas. 15 in the next category, 32 in the next category, 27 is the next category, and 26 is the next category. Altogether, there are 114 colas out of 240. Therefore, the probability of finding a female cola among this batch would be 114 over 240. The next problem is to find the male cola between 75 to 85. Now see, with the 75 to 85 category means what are the columns we have to, what are the cells we have to consider for this question. So you can say it's a male between 75 to 85. So that means it should be 75 to 80 is a one group out of the male group, and 80 to 85 males also the another group. Therefore, we can consider the group of 75 to 80 male. There are 24 elements, and 80 to 85 males, there are 47 elements. Altogether 71 elements out of 240. That would be the probability of observing a male cola between 75 centimeters to 85 centimeters. In this question, the question is histogram shows the distribution of males in kilograms of 70 adult cats. This information represented in a histogram. So there are different ways of representing the information for in our probability question. The first question is find the probability that cat chosen has a mass less than 4.5 kilograms. Then see whether what are the categories belongs to 4.5 kilograms. That is, so you can say the first two columns, 3 to 4 and 4 to 4.5 column. Those are the two columns included into the elements belongs to this category. Then we know that in a frequency density table, how do we calculate the number of elements or the frequency? We know that frequency density is equal to frequency divided by class width. Then if you cross multiply, you can say frequency equals to frequency density into class width. We know that frequency density is the height, class width is the width. So height into width or length into breadth. That means the area of this rectangle represents the frequency in a frequency density table. Then therefore we need to calculate the area for the category of 3 to 4 and 4 to 4.5. 3 to 4, the category is, the area would be 13, and 4 to 5, that would be turned up into 6. With that you can get the total number of elements, 19 out of 70 adult cats. So the probability would be 19 out of 70. Then we need to work out the mass more than 6.5. Therefore we need to calculate the area from 6.5 to 8. 6.5 to 8, the width is, or the length is 1.5. That is, you have to count from 6.5 to 8. That is the length of this bar. That bar belongs to 6 to 8 bar. I am referring to from 6.5 to 8. The length of the bar is 1.5, and the height, according to this scale, height is 4. So if you multiply 1.5 by 4, you get the area as 6. So the frequency relative for 6.5 to 8, that is more than 6.5, would be 6 out of 70. So therefore your final answer should be 3 out of 35 if you simplify with that. Venn diagrams. What do you mean by a Venn diagrams? We know that Venn diagram is used to represent the events graphically. So from our small grades from IGCSE classes even, we used to draw the Venn diagrams. Then when you mark a Venn diagram, it's essential to mark the universal set. What do you mean by this universal set? You know that relative for an experiment, if you get all the elements as a one set, we call it's a universal set. For example, if you conduct some experiment based on your school or college, if you get all the information collected from that school or the college, is called the universal set. So we use the notation called epsilon to represent the universal set. Let's try to mark information on a Venn diagram. This Venn diagram represents for elements in set A. If they ask you to mark set A, you can consider the region colored in this diagram. So some part of a B, elements in B may be colored into this as a region. The reason is that there is an intersection between A and B. Therefore, you have to understand that if you want to mark the set A, you have to consider the region colored in this diagram. This diagram represents the region belongs to complement of A. What do you mean by complement of A? Complement of A means the region belongs to not A, or other than that not belongs to A. You have to consider the region rather than that A for the region of complement of A. Therefore, some part of B may be colored, but you not should color the area which is inside the circle A. This is how we have to mark complement of A. This is the region belongs to B. Since there is an intersection with A, some part of A may be colored, but there is no specification indicates with A. So if they ask you to find the region belongs to B, you have to consider the region colored in this diagram. This diagram represents complement of B. What do you mean by complement of B? Elements not belongs to B. Therefore, you have to mark all the region outside from B. Since there is an intersection between with A, some part of A may be colored, nothing to worry. If they ask you to mark complement of B, color everything outside from circle B. This is another special area most of the students confuses. Here we need to mark A intersection B. Means you have to understand what do you mean by intersection. Intersection mean the common area. So if you color A, you can color the entire circle A including part of B. Then if you color B, you can color B including some of area over here. So if you consider about the intersection means the region where intersect each other. So that is the area you can, it's shown in the diagram, that is what you represented by A intersection B, or the common area for both A and B. That is what you mean by intersection. This is A union B. What do you mean by A union B? A union B means element belongs to set A and set B including the common elements. Therefore, if we refer to find the elements or area for A union B, you have to mark everything considering A, B and its intersection. I think you can understand the difference between intersection and union. If they discuss about intersection, you have to find the common region. If they ask something related to union, means you have to mark everything for this given set. That is what you have to understand from this section. When you refer to this diagram, it indicates A complement intersected by B. What do you mean by A complement intersected by B? A complement means which is outside A, which is not belongs to A, intersected by B. That means the common region for A complement and B. So if you get the complement of A, you have to get the region which is outside from A. Then if you get the region belongs to B, you have to get the and everything in the circle of B. Then you have to understand that what is the area those two sections were intersected. That is how you have to understand about A complement intersected by B. This area represents A complement union B. First we have to color the A complement area which is outside from A. Then color the region which belongs to B. Then after that identify entire colored region. So you just take a piece of paper and color A complement. Then color B. Then after that you can see the region which is colored anyway. That is considered as A complement union B. That is the simplest way of identifying the union between A complement and B. The other way of reading this area is the area belongs to complement of A. That means not A and B. That is the way you have to understand about the region belongs to given shaded region. Let's try to understand this region. This is A union complement of B. That means the region belongs to A and outside B or complement of B. To understand the region clearly, the easier way is that first color A. Don't consider any other facts which is related to this question, just color A. Then color B complement. If they specifically say union, consider the region colored by any of the way. That is the simplest way of identify the region for a union. This is the region belongs to A intersection B complement. To identify this region, the easiest way is first color A. When you color A, just ignore any other facts in this question as I mentioned in the previous question. Color everything in A. Then color B complement outside B. Now to identify this intersection, this is common for any union or intersection. If it is intersection, consider the region colored in both methodologies. When you color A, use one color, and when you color B complement, use another color. Then after that, see whether which is the area colored in both techniques. That is the area belongs to intersection. In any case, if they refer to A union B complement, consider the region colored in any of the way. It doesn't matter it's cross section or cross colored even, doesn't matter whatever the way, you just consider the region which is colored in any of the technique. If I repeat this technique, first color the given region. For this question, first you color A, then you color B complement. Here the section is the intersection, then therefore you have to consider the region colored in both techniques, or other than that we can call that as a cross lines. Then if they specifically mention union, nothing to worry about the cross lines or anything, you have to consider the region colored in any of the way. That is the simplest technique of identifying intersection and union. So here it's intersection, therefore you have to consider the region which is colored in both techniques. This question is A intersection B whole thing complement. If you have some kind of a bracket complements in a question, first you have to understand the region belongs to the section which is inside the bracket. That is A intersection B. No? Therefore, that region which belongs to A intersection B is the intermediate value, intermediate region from A, and we already knew from the previous section. Then that region complement. So keep that region blank and color the region which is outside from that way. So that is the way of identifying A intersection B complement. This is the region belongs to A union B complement. Initially consider the region A union B. We know that from our previous diagram, A union B is the region which belongs to within inside the circle A and B. Then if you consider A union B complement means outside from those two circles. That is how we have to identify A union B complement. If I repeat it back, initially consider the region A union B, that is inside the circles A and B. Complement means totally outside from that. That is what you mean by A union B complement. In these slides, we have to go learn about how to input information into a Venn diagram. This region belongs to elements in A. In a specific question, if they mention some kind of information in A, you have to understand that those information should include into everything inside this circle A. So part of that information goes to only for A region, and other one is other part of this information goes to the intersection between A and B. If a specifically question in a question, if they read out as some kind of element belongs to A, you have to understand that those elements should be included into everything inside this circle A. For example, in a question, if they say out of certain set of students in a school, some part of a student, suppose that if you get 50 students study arts, I use letter A, arts, 50 students study arts. So in that case, you have to understand that 50 students belongs to the region only for A, that means which is from left side from the circle, and as well as part of another student should enter to the region where it belongs to A and B both. So when you mark 50, you have to see that the two portion comes to one portion come to intersection, and other portion should come up to the region A only. In same way, this is the region belongs to elements in B. For example, if they say out of a certain set of students in a school, 100 students study biology. That means this 100 belongs to part of for A intersection B and other part only for B. Therefore, that 100 should be splitted among the two regions given in this diagram. So that is the difference you have to understand when you happen to ask some elements in section B or set B. This is the section belongs to elements only in B. In previous question, that area is elements in B. So if they mention elements in B, some part of elements can include into the section between A and B as well. If they specifically mention elements only in B, you have to include those information into this region. For example, if they mention some part in that, when some kind of a question, if they say out of certain set of students in a class, 25 students study only biology. So in that case, you have to include that 25 into this region, not the intersection region. If they mention that 25 students study biology, that means part of goes to this region and other part goes to the intersection region. But if they specifically say 25 students study biology only, means this is the region. Or other way you can say 25 students study biology but not art. There are two ways you can say. Sometimes they used to say only biology, sometimes they mention biology but not arts. Just like that, you have to understand this is the region belongs to elements only in B. Okay, here you can see there are three kind of sets for involving with this question. In this question, if they specifically mention elements in only A and B, you have to consider the region as only this shaded region in this question. But if they mention elements in A and B, if the only term is not there. Therefore, you have to consider this region as well as intersection between three elements A, B and C also. But if they mention elements only in B, this is the region. But if they mention elements in A and B, you have to consider the regions, the shaded region over here and the intersection between all three regions A, B and C as well. Now let's try to understand this question. Here they mention there are 25 students in a tutor group at a college. That means this 50 belongs to everything in this set. That means the region belongs to the first part of a circle, intersection, the second part of the second circle and outside region as well. Then we can mark it as the students, in the college study arts and music. There are two variants, arts and music. 48 students study arts. Therefore, they haven't mentioned study arts only. Therefore, this 48 out of elements in 48, some part belongs to arts only and another part belongs to arts and music both sections. Then they mention 35 students study music. That means this 35 out of the region, out of the elements belongs to 35, some part belongs to only music and some part belongs to the intersection between arts and music as well. Now let's try to solve this question. Out of 48, we don't know what is the proportion goes to only arts and what is the proportion goes to the intersection between arts and music. Therefore, I'll consider the part belongs to the intersection between art and music as X. We know that this 48 belongs to that intersection and purely only for arts. Therefore, if the intersection region is X, other part we can mark it as 48 minus X. Then we know that out of the elements in those in music 35, some proportion goes to the intersection, other part goes to the music. So in that case, if the intersection is X, other part would be 35X. Then if you add up all the elements in these three marked regions, that should be belongs to how much? That should be belongs to 50. Therefore, you can say 50 equals to 48 minus X the first region, plus X the second region, plus 35 minus X is the third region. If you simplify this, you will get the answer for X as 33. That means the intersection region is 33. Therefore, only arts region should be 48 minus 33 and only music region would be 35 minus 33. Therefore, we can complete the region as purely there are 15 students study only arts, 33 students study arts and music both, and 2 students study music only. So this is the way of representing that information on a Venn diagram. Okay children, in next video I will meet you with discussing problems involving with Venn diagram. Hopefully you have understood the basic contents in this video. If you like this video, put a thumbs up. To watch more educational videos, please subscribe my channel and share this video with your friends.